Okay, we are on now. Good afternoon. I hope you are here now. Gentlemen and ladies, if you have any issue, you can send message on the chat. All right. So, still waiting for you guys to join. Okay. 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 We have about 4 people now. 4 people are online. So we are still expecting others to join. Expecting others to join. Okay. So today we want to look at this topic, the advanced computer components. We want to learn about advanced computer hardware components necessary in setting up a computer. All right. Among the things we are going to learn include how to configure the BIOS, UEFI. We are going to talk about the POST, the BIOS, the CMOS. We're going to talk about electrical power. We're going to talk about the wattage and voltage of the computer system. Also, we're going to talk about CPU architecture, computer upgrade, how to select components to upgrade a computer. Then we're going to talk about protecting the environment. What are some of the things that we need to dispose and the safe disposal methods? So we're going to talk about that so that we could learn how to save the environment. So we are expecting others to join us here. Okay. Right. We are now 9. Okay, you are welcome. If you can hear me, please type into the chat box. Let me see your comments. If you can hear me live, let me know. Okay, I could see Azizat Ayomide. How are you this afternoon? I could see your chats. So you can say something by sending message into the chat. If you can hear me, type into the chat box. Let me know whether you are hearing me. Okay, Azizat, if you can hear me, please type it. Let me see it that you are actually hearing me. All right, we are still 9. We are expecting more people to join us in this live lecture. All right, that's fine. So we will begin the lecture and then others will be joining us. All right. will not stay too much. We take as much as time permits. We will not stay too much on the lecture so that we don't waste our time and the data on our network. All right, I could see Moise, Lawali Moise. I could see Peace Eniola. I could see Bowen Official, Mohammed Nahid. All right, you're all welcome to the lecture. Okay, Peace Eniola saying good afternoon. I can see that. I can see you. Nahim HOC, I can see you. All right, so you are all welcome. So the number keeps on increasing now. So we want to go on with the lecture. So you can jot, you can ask questions in the chat box. All right. So the first part we are going to talk about now is POST. POST is power on self-test. When a computer is put on, when it started, it begin booting, and then in that process of booting, the computer runs a check called here. The computer runs through all the hardware installed so that it can actually ensure that all the available hardware, they are ready for starting up the system. That is power on self-test. The basic input and output system BIOS is that's designed to run that check on all the hardware. Now, when a device is malfunctioning, what happens is that there's going to be an error, a beep code that alerts the user that there's an error. And then some missing components may not make the computer to boot. For instance, if there's no hard drive installed, or perhaps RAM is not installed or not properly seated on the motherboard, the computer will bring an error code and then it will stop booting. All right. So these codes have been prepared by and then it will stop booting. All right. So these codes have been prepared by manufacturers to inform the technician. When they read the code, they'll be able to determine which hardware is having an error and to be able to troubleshoot and correct that. So to actually know the meaning of some code, one needs to consult the motherboard documentation to get the bit codes for a particular computer. Now, if you want to know whether your bit code or your POST is working properly, what you do is that you can try and remove the RAM, open your system, remove the RAM, and then try to turn on the system and see what happens. If the POS is working properly, you see an error that comes up, and the computer will inform you with bit code that RAM is not installed. So that's a way to determine whether your POST is working fine. So BIOS is what a computer needs to actually operate to start up. It's a program that is stored on a ROM chip on the motherboard. It's a small program that controls the communication between the operating system and the hardware. Now, along with the POST and the BIOS, the computer will be able to identify which drives are available, which drives are bootable, how much of the memory is available and configured and can be used. It will check about PCIe expansion slots, and then the way they are configured. It will check how SATA and USB ports are configured. And then it will also look for the motherboard power management features. It's part of what the computer will check. All right. Now, these settings of the motherboard of the BIOS is stored in a chip, a CMOS chip, that is complementary metal oxide semiconductor. The settings are kept there permanently. And this chip requires a small power. That small power is supplied by a small battery that is included on the motherboard. Even when the system is power off, that program in the BIOS requires small power to continue running so that the system is up to date. So that power is provided by the CMOS battery. If you open the computer, you see a battery, a flat battery, almost like that of your calculator. And that is the CMOS battery on the motherboard. All right. These settings are maintained just like that by the battery. Okay. Now, When this battery is going bad or it has run flat, finally, what you discover is that your computer's date and time will be always incorrect. So if you turn on system today, you set the time, after you shut down tomorrow, you open the system again, the date is incorrect again. That means your CMOS battery is weak or has run flat and it needs replacement. All right. Okay. Now let's talk about BIOS, CMOS, and UEFI. Now, most of the systems today, most of the computers today run UEFI, that is Unified Extensible Firmware Interface, rather than BIOS. BIOS is the older version that computers run, but nowadays, new computers use UEFI. The UEFI runs on 32-bit and 64-bit systems, and then it makes the computer to be able to support larger boot drives, and then some other additional features also, such as secure boot is provided by UEFI. So UEFI can do everything that BIOS did in older computers. And then but it also does more than that. It does more functions for the computer. So for instance, the secure boot ensures that the computer boots your specified operating system, and it prevents rootkits from taking over the system. All right, UEFI is what does all that. Okay. Now in this section, when you log on, you watch a video about the configuration of UEFI and BIOS in your system. You learn about boot options, security setting, interface configuration, firmware backup, and update tool. All right. Then also, we want to mention about security, BIOS and UEFI security. There are various ways by which this section of the computer can be secured. One of such ways is by using passwords. You can password your BIOS so that before someone can actually check what is inside the BIOS, the settings, probably modify some things, you need to to apply a password. Another one is drive encryption, and this one is another way by which you can secure your hard drive by encrypting the hard drive to prevent any data theft. Also, we have LoJack. LoJack is another security feature that allows the owner to locate, lock, and delete the device. Then we have TPM, that is Trusted Platform Module. That's another chip that is designed to secure hardware by storing encryption keys, digital certificates, passwords, and data. These are security on the system. Then we have what we call secure boot. It's another UEFI security standard that ensures that a computer boots only the operating system that is trusted by the motherboard manufacturer. So those are ways by which BIOS and UEFI can be secured. Then the firmware on the BIOS or UEFI can actually be upgraded or updated. That can happen if the manufacturer of the motherboard actually releases another update. So you can actually connect to their website to electrically, download the new version of the software, of the firmware, to update your BIOS or UEFI. Older system, that is early computers, they don't have this opportunity because they have only they were produced with a ROM chip whereby you cannot actually upgrade the BIOS. But nowadays we have what we call electronically erasable programmable read-only memory, EEPROM, serving as a BIOS chip. So this one, you can upgrade the firmware on it by using the electrical method. By connecting the device to the manufacturer site, you can actually erase the firmware and download another one save to it. And then when you do this, we call it flashing the BIOS. Flashing the BIOS. That is when you upgrade the firmware that is stored in the BIOS and update it to a newer version that has been released by the manufacturer. It's called flashing. Flashing the BIOS. To do that, you need to consult the manufacturer's website and follow the recommended procedure to achieve that. Okay. Now let's talk about electrical power. The computer system is an electrical appliance, as we all know, and so it's taking power from a utility supply or from a personal standby power supply like your inverter, like your backup generator, and so on. So we need to know about wattage and voltage. Now for voltage is measured in volts, and that is the work required to move a charge. Now current is what the computer draws. When you supply the computer with voltage, the devices inside the computer will draw the current to make them operate. Now we also have resistance, which actually is an opposition to the current supply. So based on the resistance of the components, it determines what level of current they can actually draw. Now power is measured in watts, and that is uh, measured as voltage multiplied by current. Of course, we are talking about DC power. When power is supplied to the computer, the power supply unit of the computer converts the AC power into DC. So the voltage, DC voltage and the DC current, when the values are multiplied, will give the power consumed in watts. So that gives the wattage of a particular computer system. Now, power supply units come in various voltages and various power rating. For instance, in Nigeria, we use 220 volts. In some other country, they use 110 volts or 115 or 120. In Nigeria, we use 220, 230, any range of voltage within that 220 to 240 can actually operate our appliances. But usually, some of them have two types of power supply. They can take in two type of power supply through the same power supply unit. So there's a switch that you can use to select between either 110 volts or 220 volts. And then some newer versions of a power supply unit, they have a regulated power supply within them, so that if you take it to a country where they are using 110 volts or 220 volts, you can take in the power and then work with it by stabilize it inside and step it down to the level the computer. Now, if the power supply does not have a switch, that means it can automatically detect the power supply, the voltage supplied, and utilize it as required. So those ones have inbuilt voltage regulator that can actually check the voltage that is incoming and then work with it accordingly. Now, power fluctuations. There could be power fluctuations, and we don't want that to happen to our computers. We don't want power fluctuations to, you know, destroy the system. And there are different levels of power fluctuations that can happen. For instance, if there is a total power outage, that's complete loss of AC power. We call it blackout. Blackout. And then we have a brownout. When the voltage supply is lower than what is expected, sometimes when you see the voltage, the electric lamp becomes very low, very dull. At that point, even though the power is not totally out, but the voltage supply is very low, we call it brownout situation. Noise, it can be caused by interference from probably generators, or sometimes when there is when there is a thunder, when it is raining and there is lightning. So those one can interfere with the electrical system of a computer. We also have spike, which is a sudden increase in voltage that lasts a short period of time. Just goes up and then goes down again. And then sometimes a spike can exceed 100% of the normal voltage on a line. What are we talking about here? If you are using 220 volts, a spike can go as high as 300, 350, or even up to 400 or more than that. That is a spike, but it doesn't last too long. It goes up like that, momentarily, and then suddenly it goes back again instantly. So that is spike. Then we also have power surge. Power surge is a kind of power increase in voltage above the normal flow of electric current, and it can spoil equipment. can spoil the equipment. So we want to protect the computer system from all of these power fluctuations. And some of the protections that we can use are this. One, you can use a surge protector that protects a computer against damage from surges and spikes. So that will be attached to the power supply outlet before you now plug your computer onto that. Then we also have uninterruptible power supply, UPS, that ensures that when there's power outage, your computer does not go off immediately. It supplies power back to your system for a limited time so that the work you are doing on the computer you can actually finish up and save and shut down the system. So the outage will not actually affect your computer when you have a uninterruptible power supply. So you can protect against potential electrical problems such as power outage. Then also brownouts, blackouts. The uninterrupted power supply, the UPS, can protect our system from that. Then the standby power supply. There are systems of power supply, for instance, the solar system, whereby you have your inverter, solar panel working together to serve as backup for the supply. So when there's no power at all, you can then revert to use this standby power supply. So they can also serve as another source of power so that work can be done, the system can continue to work. All right. Now, we want to talk about some of the additional computer functionalities. First, we want to mention the CPU architecture. There is a program stored inside the computer that runs and executes instructions according to the program written. Now, there are two ways by which these programs can be written for the CPU to execute. We have two major systems of programming for the CPU. One is reduced instruction set computer, RISC, as RISC. Here, the programmer uses less, relatively small number of instructions because these instructions are designed to be executed very rapidly by the CPU. Whereas the other one, complex instruction set computer, CISC, that this situation we have long list of program, and then it means the computer will take fewer steps per operation. All right. So that is two ways by which programs are written for the CPU to execute. Now, the program of instruction in the CPU sometimes are in form of data that are stored in the special cache memory inside the CPU. And that is a very high speed memory made from SRAM. That is the fastest type of memory, synchronous random access memory. All right. So I hope you are following. Now, at this point, I don't know whether some of you that are here have any question. So I could see Olawale Mui is typing question. Typing I have a question. So please, you could type your question. Let's say something about that. Okay, let's see. Muiz, let's see your question. Okay, while waiting for that, let me let me continue by mentioning the next point, and that is how to enhance CPU operation. That is how to make the CPU work better or faster. So there are two major ways by which CPU are, you know, designed to make it work faster. One with Intel processors. Intel, that is a integrated electronics. That's a giant in the computer processor production. That's a giant. Okay. Now they are they use the technology called hyperthreading. Hyper Several pieces of codes are executed simultaneously in the CPU so that the CPU performs as though there are two CPUs. So the CPU can perform as if there are many CPUs together when you use hyperthreading. Whereas for the other company, AMD, their own processors use what they call hypertransport. Hypertransport. AMD is a advanced micro devices. Advanced micro devices. That's another computer CPU producer, another giant. So they use hypertransport, which is actually a way by which the CPU can communicate with high speed with the NOT bridge chip. And so the function of the CPU in that way can be faster than before. Now, when we talk about the speed of the CPU, is measured in gigahertz or sometimes megahertz. That is how many cycles per second that the CPU can actually cycles per second. So when we say megahertz, we are talking about millions of cycles per second. When we mention gigahertz, we are talking about billions of cycles per second. Billions of cycles per second. That is a gigahertz. Now, I see someone asked a question. What is UEFI? UEFI, Unified Extensible Firmware Interface. Unified Extensible Firmware Interface. That is the meaning of a UEFI. Let me just post that in chat so that you can see it there. All right. Okay, somebody asked another question. The two ways in which programs are used to execute. RISC. That's a RISC. RISC. And CISC. That's the way a computer system executes programs. Programs are written for the CPU to execute. RISC means reduced instruction set computer. CISC is complex instruction set computer. That's the full meaning. All right. Yes, Eniola is asking about increase in voltage, spike for a short period of time and later drop. Yes. When it drops, will it drop drastically or we go back to 220? Yes. When the voltage goes up, will it drop drastically or we go back to 220? Yes. When the voltage goes up suddenly, it goes back to the normal. Goes back to the normal, and then it doesn't stay at that high voltage for long. So it quickly goes back to the normal. So that is that, Eniola. I hope you can hear me now. RISC, reduce instruction set computer. Let me see if I can copy that and paste for you. Instruction set computer. That is RISC. And then CISC, complex instruction set computer. Okay, complex instruction set computer. That's it. All right, let me just type it to the chat for you. That is RISC and CISC. The second one is CISC. Okay. Complex instruction set computer. All right. So that is the meaning of RISC and CISC. RISC and CISC, they are the technologies by which the system by which programs are written for the CPU to execute. With RISC, we have fewer number of programming codes for the computer to execute, and it executes this instruction very fast. Whereas with CISC, we have many more several to execute. All right. So I think we can go back to our CPU operation enhancements, how we can enhance the CPU operation. That is, how you can make the computer to work faster. We made mention of hyper threading and then hyper transport. Hyper-threading is for the system, the CPU produced by Intel. They use that technology. Whereas the other company, AMD, they use the technology of hyper-transport that makes the CPU to communicate, to send data fast in a high-speed connection between the CPU and the NOT block. Transport that makes the CPU to communicate, to send data fast in a high-speed connection between the CPU and the NOT bridge. All right, that is that. Then I mentioned the unit of measurement of the speed of the CPU, that we measure it in megahertz or gigahertz. Now, megahertz means millions of cycles, and then gigahertz is billions of cycles per second. Excuse me. Now, another way by which we can make the computer to work faster, than this is what a user can do. In the BIOS, there's a way by which we can actually make it faster by adjusting the settings in the BIOS, the clocking of the computer. The clocking is what tells the computer when to execute next, instruction. How fast it's going to execute these instructions is determined by the clock. We call something in electronic system, we call something clock, that tells the computer operate, and then the clocking will be going steadily at a regular interval. Now, when you go to the BIOS and adjust this setting, you have to. This is something that will require that your computer have a very good cooling system, because at this point, when the computer works faster than what the manufacturer has actually set, then it produces more heat. The CPU produces more heat, it generates more heat, and then it needs to be cooled down. So if the cooling system is not working fine, then the CPU can get damaged by the heat generated by itself. All right. Now, the opposite of that, opposite of overclocking, is what we call CPU throttling. Now, when you reduce the speed, you adjust the speed in the BIOS at which it operates at the clocking speed. You reduce it so that the computer now works slower than before. Then we call that CPU throttling. Then the computer process runs at a less speed than the rated speed, and then conserves power and produces less heat. Conserves power because less electricity will be required to run, and then heat also. All right. Then virtualization. CPU virtualization is a feature of the CPU by which supported by both AMD and CPU, AMD and Intel CPU, that ensure that a single processor can act as multiple processors, so that on a single computer system, two or three or more computers can be installed, running different software, but using the same CPU, as if we have more than one CPU. That's a CPU virtualization. Now, it runs more operating system. More operating system will be running in parallel on the same computer. And this operating system, they are referred to as virtual machines, because they are not the original computer. The original computer is the host, where those ones are called virtual machines. Now, gentlemen and lady, I hope you are following. I want to ask you that how long should we stay in this level today? So you can answer that in chats. How long should we stay? We have stayed about 34 minutes right now. Now we are talking now about, we want to mention multi-core processors. Multi-core processors, that's another way by which CPU operation can be enhanced. Multi-core processors are these advancements in the CPU technology, whereby only one CPU has inbuilt within itself two or more processors on the same integrated circuit unit. So that is a multi-core processor. Early computers run only one CPU core, but with advancement in technology, many more CPU cores can be built into the same, CPU, and that is called a multi-core processor. And this makes the processors in the multi-core be sharing the same RAM that is available on the system. All right. And then with that, we'll be able to conserve power. They conserve power, they produce less heat, the process produces less heat, and then increasing the performance and efficiency of the computer, stored into the same computer. In that case, then the computer will produce more heat, takes more energy, more electric power to run than when you have a multi-core processor, a single unit that has several cores within it. So we can talk about a single core processor, that is only one core, only one processor within the chip. Then we have the dual core, the triple core, the quad core, the hexa core, and the octa core. So that is how the generation of a CPU goes from dual core, two core, triple core, three core, quad core, four. Okay, I could see your answer to that. That maybe when we spend 1 hour, we can call it a day. Now, for multi-core processors, another function that is found in a CPU, the GPU, the graphic processing GPU, within the CPU and dependent on the RAM of the computer. All right. But dedicated GPU, they are not embedded. And these integrated GPUs are good at less complex tasks like watching videos and processing graphical documents, but they are not best suited for intense gaming applications. So dedicated GPU will be better. As we know, computer system produces a lot of heat, and then there are cooling system introduced into the computer so that it can be cooled down and not run bad, not be destroyed by the heat. So we have a fan attached to the case, of the computer that is removing the heat, generated by inner components in the computer. Generated by inner components in the computer and bringing it out. This fan is working such that the air generated by the CPU is absorbed by the heatsink, and the fan blowing air to the heatsink will remove the heat from the CPU. Now, when you cool the CPU without using electricity, that is without a fan, that is regarded as passive cooling. Like the heatsink now. Heatsink does not use any electric energy, it's just aluminum metal that can absorb heat and radiate the heat away. That is passive cooling. But when you use when you use fan to cool the CPU, that is regarded as active cooling. All right. Then the graphic card in the computer system also require its all right. Then the graphic card in the computer system also require its system having an attached so that I can cool it, because that's a particular module can actually produce a lot of heat. Then nowadays, with advancement in technology, we also have water cooling system. That's almost similar to how you use water to cool a motor vehicle. So water cooling system to cool down the processor. The water is pumped like a radiator that disperses the heat into the air, and then the water is recirculated just like it happens in motor cars. All right. Now let's look at the ports available on the computer system, the legacy ports. We're going to talk about the connectors and the cables. We have the serial ports. Serial ports is used for connecting various peripherals such as printers, scanners, modem, console, and connections to network devices. That is a serial port. The serial port is 25 pins. Nowadays, most desktops and laptops, they don't have parallel ports any longer. They don't have. Commonly, in the past, this port is used for printer. The printer is connected through the parallel port. Then we have the game port. Game port that is used to connect a joystick to the computer. Then we have the PS2. The PS2 port, you will see one green color round port, and one like a purple color, or do I say pink mouse to the computer. But nowadays, keyboard and mouse are connected through USB ports. I think we can continue a little bit and then we will wrap it up. Now let's look at video and graphic ports. We have the VGA ports. VGA ports, that is what we use to connect the projector to the system. Then we have the DVI port. It's another special port on the computer system. Then we have the HDMI. HDMI almost look similar to the USB port, but it's having two corners and control signals. Also, cables and connectors, the USB, we have the evolution of USB from USB 1.0, USB 2.0, USB 3.0, and USB 3.2. Then we also have the USB Type A, USB Type A. We have the mini USB and we have the micro USB. We have USB Type B, we have USB Type C, and then we have the lightning cable, lightning plug that goes into the computer. Then we have the SATA cables and connectors, SATA cables for power and SATA cable for data. So we have them. Some of these cables are replacing older cables such as the high DE cables. Then we have the eSATA, the original cables that the computer used in those days, but they are no longer used. The cable inside. So and then this has a kind of a shield, kind of a aluminum shielded a twisted pair cable to the system. And then we have RG45 plug that we use to connect the cables, the four bands of twisted pair cables together. All right. Okay. I can see that go online and see the video on the on the you know on the channel, on this YouTube channel.